magnetic field due to circular coil. Here we considered a circular coil of radius A and center O, through which current I is flowing. Okay. Now here P is a point at a distance x from the center of coil. And now this current I produces magnetic field at a point P, which we have to calculate now. For that, we considered a small element AB of length dl on a circular loop, right? Join this element with point P. So here we joined the element with point P. Let it be R, making an angle theta. This element is making an angle theta with line joining the element to the point P. Here the angle be pi, that is angle between the straight lines OP and BP we took as pi. Okay. Now from Biot-Savart law we have mu naught by 4 pi I dl sin theta by r square, which is nothing but the field at point P due to current I flowing in element AB. Okay. So now here theta will be 90 degrees because the dl and r are perpendicular to each other. So here you see, if this is the circular coil we assumed and these are the element AB which we took, now this becomes dl, the length of the element, and this is the r, this one is the r drawn to the element AB. So now see, here this r is perpendicular to the element AB. So only dl and r are perpendicular to each other, so theta becomes 90. So now dB equal to mu naught by 4 pi I dl sin 90 degrees by r square, which is nothing but equivalent to mu naught I dl by 4 pi r square. Let us take it as equation 1. Now we want net magnetic field at point P due to whole circular coil. For that we have to resolve dB into two components. Okay. So first, now this is a straight line joining B to P, that is R. Now for this R, this becomes perpendicular. So this line becomes perpendicular line, and along this we have the direction of magnetic field dB. Okay. Now here you see, this is the angle pi we are saying here. This is the angle pi. Then this angle, what it becomes? 90 minus pi it becomes. Okay. This angle totally it becomes 90 minus pi. Now here we have to resolve the dB into two components along the axis of the coil. Okay. So one is the at right angles to the axis. This is the line which we drawn. Other is along the axis. Now when this angle is equal to 90 minus pi, then this angle, this one becomes pi. So components along the pi is taken with cos pi. So dB cos pi, and now this becomes dB sin pi. So now dB component to the right angles to the axis is dB cos pi, and along the axis is dB sin pi. Similarly, if we take another element opposite to AB, that is A dash B dash. Now if we join, again we can write it as R, as of same length. Now this becomes the perpendicular of this R. Now as usual, now this angle, again we can resolve dB into two components. One is the perpendicular to the axis, other along the axis. So when this angle is 90 minus pi, this angle becomes pi. we write it as d pi cos phi, and perpendicular to the pi and along plus x axis dB sin pi. Okay, so now the net magnetic field will be due to the perpendicular component along the axis and parallel component along the axis. As parallel components are along the axis, they add up with each other. And see the perpendicular component. One is in such a direction, upwards. Other is in a direction in opposite sense to the first one. So the net effect, as they are of same magnitude, the net effect of these perpendicular components will cancel. So now the net magnetic field is only due to these parallel components, integral dB sin pi. Okay, and now from equation 1 we are substituting the dB value in equation 2. So we get integral mu naught I dl by 4 pi r square sin pi. From diagram, sin pi value is here the angle pi. Opposite sin pi will become opposite side A, hypotenuse r. So A by r. We substituted A by r here. So we got mu naught I by 4 pi r square integral dl A by r, or that is equal to mu naught I A by 4 pi r cube integral dl. Here integral dl is nothing but the circumference. The circumference of a circular coil. As A is the radius, the circumference becomes 2 pi A. Okay. So now substituting this value, we get B equal to mu naught I A by 2 pi r cube into 2 pi A. Sorry, 4 pi r cube into 2 pi A. So 2 remains mu naught I A square by 2 r cube. Now once let us take a look towards the diagram. Okay, now see here, we want the value of r square. Now if we consider this triangle, what will be r square? X square plus a square. Okay, so from figure, r square is equal to x square plus a square, or r equal to x square plus a square 1 by 2. Okay, so substituting, we get B equal to mu naught I a square by 2 a square plus x square, here cube is there, whole to the power of 3 by 2 Weber per meter square or Tesla. If n terms are present, then it becomes B equal to mu naught n I a square by 2 a square plus x square whole to the power of 3 by 2 Weber per meter square. Weber per meter square. Mu naught n I a square by 2 a square plus x square whole to the power of 3 by 2 Weber per meter square is the required magnetic field produced at point P due to current I flowing in the circular coil. If we consider the cases, the first case is when point, now this is the circular coil, no? Okay, this is the center. We are saying when point lies at the center. Now what happens when point lies at center? X becomes 0. So equation becomes B equal to mu naught n I a square by 2 a cube, or that is equal to mu naught n I by 2 a. Okay, a square, and here a square strikes off, a will remain in the denominator. Now next, if we consider case 2, when point is far away from axis. In such case, a square plus x square whole to the power of 3 by 2 will be approximately equal to x cube. So substituting, we get b equal to mu naught n I a square by 2x cube Weber per meter square.